Okay, a very good evening to all the learners. Okay, I hope all of you are doing well. Let me just confirm if I'm live. Give me a moment. I'll just be checking it. Okay, yes. I'm live, I guess. Fine. So, welcome you all. I welcome you all in this particular session. See, guys, this is the first session on fluid pressure. I mean, for term 1, class 9, this is the first time that I'm discussing fluid pressure. So I'm sure the session is going to be very informative for all the learners. And see, you might think that, sir, ये तो chapter number 4 है. I mean, why would we start from this particular topic? Fluid pressure has nothing to do with the previous chapters, neither motion nor laws of motion. It's a different concept altogether and a, a little tricky, you can say. It's a little tricky. So in case you are done with the revision part or you're done with the basic introduction part in the beginning itself, I mean, it is an added advantage for you, right? So that is why I have deliberately scheduled this session at this particular time. Fine. And I'm sure once you are in the session, you'll not regret attending it, right? So before I begin the session, I guess let me first introduce myself. My name is Kalyan K Awasthi and I'm a physics educator at Unacademy. As far as my qualifications are concerned, I have done my BTech in Electronics and Communication Engineering. I have done my Masters in Digital Communication, which again is a specialized branch of Electronics and Communication Engineering. And guys, I've been teaching physics since 2008. So yes, I mean, that's a long time. So yes, you can very much make use of my experience and I'm sure it will be reflected in this particular session as well, right? Chal. So before we begin with the session, let me introduce you with the two groups, the two class 9th and 10th Unacademy groups that we are having, the Telegram channels that we are having for Unacademy, right? The very first is the general Unacademy ICSE and ISC group. I'm sure many of you might be new to this because since we are starting with class 9, so we might have a base of new learners. So yes, this is the first Telegram channel. The general Unacademy ICSE ISC channel where you will be getting the information of all the upcoming offers. All my upcoming session details will also be communicated in this particular Telegram group. Now secondly, this is the Telegram physics channel that is managed by me. You can be a part of it if you want to get access to the notes, to the questions, to the polls that I periodically give to all my learners. So this is the right place for that, right? So if you have not joined these two Telegram channels, this is the right time. See, the session that you're watching right now is a YT session. Apart from these YT sessions at Unacademy, we are having special classes, right? Now, let me first brief you about the features of these special classes. First of all, you get to learn from your favorite educator. So, I mean, that is an added advantage. And the icing on the cake is it's absolutely free. Okay. These special classes are meant to, help the learners have a feel of the portal. And I'm sure once you are attending the classes, you'll be literally bowled away with the sort of features that it is having. So the special classes for you is absolutely free. You can be a part of it. You can watch these special classes. You can unlock the previous classes by using the code. My YT code is Kalyan Live. You can use this code to unlock all my previous classes. Secondly, in these special classes, you can engage with the educators through polls. Now, what are polls? Polls are important MCQ questions that we have, and these questions we do through polls. And in a poll, you get to see how many of you have given the correct answer and what was the time that was actually taken in giving those answers. So yes, it relies on two parameters: accuracy as well as your the time taken to do the questions. And we have this doubt tab as well in a special class. What is a doubt tab? Let me brief you. Through a doubt tab in the middle of the session, if you have any doubt regarding any topic, you can get that doubt clear. So that is again an added advantage that we have in this special class, right? So this is the link of my next special class. It's falling day after tomorrow, 7:45 p.m. I'll be introducing the learners to the concept of the displacement time graph. So if any one of you wishes to, join this class, I mean, you're most welcome. I'm sure it will be a great experience for you guys, right? So this is the link for the, I mean, this is the detail for the class, right? You can find the link in the description box. See, apart from the special classes at Unacademy, we are having plus classes. Now, plus classes, let me brief you about the features of the plus classes. Pictorially, it is represented. The very first thing is that you get to learn live. The classes are live, so that is the best part. Second, if you are a plus subscriber, you can get the access to all the courses unlimited number of times. Now, this is a very good thing. You can access the courses any number of times you want. You're taught through the top educators of the country, so that is an added advantage. There are regular doubt clearing sessions, the answer writing strategies which help a learner to kind of develop themselves. Then you have this exhaustive coverage of syllabus, and these are few other salient features that we offer to a plus subscriber. So in case you wish to be a plus subscriber, this is the pricing page. This is the page. You just have to download the Unacademy app. You will be landed up to this particular page, and this is where you have to use my code Kalyan Live. If you're using this code, you will be getting 20% discount till midnight today. Okay, it's a great offer that Unacademy has come up. So from 25th to 28th, the discount was 20%, and 20% is a great discount to offer, right? So you can avail this benefit and you can be a part of this Unacademy family, right? This is the offer that I was just telling you, the 20% one. This is my code Kalyan Live, right? You can use this code. Just look at the pricing. If you're going for a 12-month subscription, you have to pay only 12,000 rupees. Just imagine, these are the regular prices. I mean, otherwise you would have to offer 15,000, pay 15,000, but now till midnight today Unacademy is offering the same course for 12,000 rupees. Now 12,000 for 4 subjects, I mean I'm speechless regarding this. 1,000 per month, and in 1,000 you're getting physics, chemistry, maths and biology. So 4 subjects, I mean 250 rupees per subject per month. I'm sure you'll be able to calculate it. अभी 250 रुपए में आपको एक सब्जेक्ट पढ़ने को मिल रहा है, that too from the top educators of the country, that too on a very very user friendly platform. You cannot ask more than that, right? Chalo, now let's start the session. See, today we're going to discuss pressure in the fluid. So before understanding the pressure, we have to understand a very very significant term, and we call it thrust, right? See, let us assume that a body is lying on a surface. There is a body and it is lying on a surface. The mass of the body is m, and say a number of forces are acting on the body. A number of forces from different directions are acting on the body, right? See, so what is thrust? Thrust is the force that is acting perpendicularly on the surface. Of all these forces, let me name them. F1, you can clearly see that F3 acts normally or perpendicularly, right? You can clearly see that F3 acts normally or perpendicularly. So this F3 will be your thrust. The perpendicular force is always the thrust. So you have to keep this in mind, that thrust is the perpendicular force that acts on the body, right? Now see, of all the forces that act on the body, there is one force that we call a reaction force, right? Abhi I'll be telling you about the reaction force in the later part of the session, but technically speaking, what we do, we consider that the thrust force is actually the weight of the body. Why? Because weight of the body also acts normally, right, from the center of mass, and so is the thrust acting. So technically speaking, in numerical questions, at times they give you mass and they ask thrust, right? I'm sure you're able to get it. I mean, they ask you mass, they give you mass, and they ask you to find the thrust. So whenever this mass is given, you have to find the weight. Weight is W is equal to mg. Now this weight will automatically be your thrust. So keep this in mind. I have a question like this in the session. So I'm sure once we do that question, you will be thoroughly understanding the concept. And yes, please like the lecture as well if you're watching it. Hi Unnati. Why should we prefer parallel? If you're using a series connection, you know, if one of the appliances fuses, the entire electricity will be gone. Why? Because in series the current is constant. In parallel the potential is constant. For example, you are using 220 volts and you have connected a number of appliances in parallel. So every appliance will get the entire 220 volt. ठीक है ना, सीरीज में वोल्टेज गेट्स डिवाइडेड. अभी 220 वोल्ट में से मान लो किसी बल्ब को 220 वोल्ट नहीं मिल रहा है, तो इट विल नॉट ग्लो अप टू इट्स ओन कैपेसिटी. So that is why preferably we use parallel connections in our appliances, right? I hope you have got the answer, Unnati. Yes, Unnati, is it clear? Okay. So see, in case of thrust, we have confirmed that thrust is acting normally. As soon as I say that the thrust is acting normally, it means that it has a direction. You could clearly see that in this particular slide, there were a number of forces, but we did not consider every force as the thrust. The only force that was thrust was actually acting normally. Okay, right? So yes, thrust is a vector quantity. Always remember this. Okay, thrust is a vector quantity, and since thrust is nothing but force, so the unit will be Newton. Okay, but here one more unit we often use, that is kgf or gf, right? I mean, this is not the kgf that I mean, not the movie kgf. It is kilogram force, and it's a gravitational unit. Okay, it is a gravitational unit of force. So 1 kgf it's 9.8 newtons. Okay, normally if the value of g is not given, we take it 9.8, unless it is mentioned कि मेरे को 10 लेना है, I'll be taking it 9.8. Okay, so that is why generically I have written g newtons. So whatever value g has, if it is at 9.8, it will take 9.8. If it is 10, it will take 10, right? So this is how it goes. Now if you have seen your book, the chapter basically deals with two important topics. One is thrust and the other one is pressure. अभी अगर मैं आपको बोलूं, just imagine a situation. This is a pillow, I mean a carpet, and this is again the same carpet or the same pillow. In case one, you are leaning, you're lying on this couch, and in case two, you are standing on the couch. Can anyone in the session tell me in which case the couch will be pressed more? In which case will the couch be pressed more? Will it be the case when you are lying on the couch, or will it be the case when you are standing on the couch? I hope you have got my question. Same body, two conditions. Condition 1, the body is lying on the couch. Condition 2, the body is standing on the couch. You will clearly notice that when the body is standing on the couch is pressed more. Okay, you will observe that ये जो आपका सोफा है ये ज्यादा दबता है. आई एम श्योर आपने ट्राई भी किया होगा. अभी आप सोफे पे लेट जाओ और उसके बाद सोफे पे खड़े हो जाओ, तो व्हेन यू विल बी स्टैंडिंग ऑन द सोफा ऑन द काउच, यू विल नोटिस कि भाई काउच थोड़ा ज्यादा दबा हुआ है. ठीक है ना? वेरी वेरी इंपॉर्टेंट ऑब्जर्वेशन. नाउ there is a logic behind this, right? And the logic here is nothing but pressure. Okay, Fine. See, if you have to express the effect of the thrust, I've just told you thrust is the normal force, and in kinematics we have already studied that whenever a force acts on a body, it has an effect. Yes, I mean force is a cause and it will definitely be having an effect. So यहाँ पर the force that we were talking about was thrust. So यार thrust का भी तो कोई effect होना चाहिए, हाँ कि ना? यहाँ पर जिस force की हम बात कर रहे हैं that force is thrust. तो thrust का भी कोई ना कोई effect होना चाहिए. I'm sure you're getting my point. Yes. The effect of thrust is basically your pressure. Okay, I'm again repeating. The effect of thrust is basically your pressure, right? So if somebody asks you what is pressure, you'll say that pressure is the effect of thrust, and technically speaking it is the force or thrust acting per unit area. यूनिट एरिया पर जितना फोर्स या जितना थ्रस्ट लगता है, that is the measure of the pressure. Okay, now the irony here is pressure is an scalar quantity. Right, thrust was a vector quantity, but my pressure is a scalar quantity, and this is what you have to keep in mind, right? Normally if I ask you what should be the unit of pressure, I mean it's very easy. You can easily tell me, sir, pressure is force upon area. The unit of force is Newton, the unit of area is meter square. So technically Newton per meter square should be the unit of pressure, and indeed this is the case, and this Newton per meter square is called Pascal. Okay, so the unit of pressure is nothing but pascals. Yes, I'm sure it is clear to everyone, right? Now if we have to define 1 Pascal, I've told you earlier as well, whenever you have to define a particular unit or a particular quantity, you have to assume some values to be 1. So let's see, pressure is equal to force upon area. Now we know that the unit of pressure is Pascal. If I have to define Pascal, what I will say, 1 Pascal is the pressure acting on the surface of area 1 meter square, or you can call it unit area, by a force 1 Newton acting normally on it. Or in other words, you can say when 1 Newton of force normally acts on 1 meter square area, then the pressure created is 1 Pascal. Right? And apart from Pascal, we have other units for measuring pressure as well, and these are bars and millibar. I mean bar, 1 millibar, this is how we do them, right? Now a very important thing, see, normally technically speaking, when we are talking about these fluid pressure, so we come to know, or we encounter a new word called fluid, right? I'm sure all of you will be able to relate with it. What is a fluid? Fluid is anything that can flow. Okay, I'll be discussing it later on, but all my dear students, the logic here is air can also flow. So yes, air is also a fluid, and since air is also a fluid, so because of air, or rather if I generalize it, because of the atmosphere around us, we'll be experiencing a force as well, rather pressure as well, and that particular pressure is called atmospheric pressure. Okay, right? The pressure which we feel because of the presence of the atmosphere, we call it atmospheric pressure. I'm sure you're able to understand this, right? You got this logic? Okay, that's great. And we are calling atmospheric, we have one more name for atmospheric pressure. We call it barometric pressure. This is the other name for atmospheric pressure. We call it barometric pressure as well. Okay, now see, this atmospheric pressure or barometric pressure, we express this pressure in terms of the height of the mercury column. Okay, in terms of the height of the mercury column, and the device used is barometer. It measures pressure. Okay, Barometer is a device that measures pressure in our case. Fine. Now just go through the slide. It's a very important definition which you might get in your examination. Just go through it. Now see, how will you define barometric pressure, right? Or the atmospheric pressure rather. Normally it is observed that the height is 0.76 m of Hg or 76 centimeter of Hg or 760 mm of Hg. Now Hg is mercury, so the most common used is 76 centimeter of Hg. Now this 76 centimeter signifies height. So in the later part of the session, you will be learning that atmospheric pressure depends on the height. So this height of the mercury column is basically confirmation on that. Okay. So this atmospheric pressure very much depends on the height. And this is one more unit that we use for pressure, torr. Okay. So now you have got a number of units: Newton per meter square, Pascal, atmospheric pressure, and now you have got torr as well. And ultimately, finally, you had centimeter of Hg. That was very much there. So you might get a question on any of these. Okay, I'm sorry for the lighting part. I mean, there are frequent power cuts and I cannot help it out, so it might be resumed in a while. Okay, kindly bear with it. Chalo. Now let's do few questions. Let's discuss few questions. Or before doing the question, if I ask you, how can you increase the pressure? Right? Pressure is force upon area. How can you increase the pressure? And this is the same logic which will answer many of these questions. Right? Just go through the questions. Just go through them once and then I'll be discussing them each. See the very first question. Why do we use pointed pins or nails? I'm sure all of us preferably use pointed nibs, or in that case if you're using a pencil, we always want it to be sharpened. Reason being, see, when you sharpen the ends of the pencil here and it comes in contact with the surface, abhi yahan par the contact area is very less, very less. As soon as it comes in contact with the surface, you can clearly see that the contact area is very less. Now since the contact area is very less, and you know that pressure is equal to force upon area, now tell me, if this is very less, what will happen? Pressure will increase. Yes. So this is, I mean, the same logic. If the pressure will increase, you will be getting a better impression. Okay, and obviously you'll have to do less effort, right? It would easily manage it, right? The same is the logic for having sharp edges. A sharp edge will have very less area of contact. The logic here is based on the area of contact of a surface. Greater is the area of contact, I mean smaller is the pressure. Why? Because pressure is proportional to the inverse of area, right? So all these questions, they have the same explanation. The logic here is obviously regarding the pressure, right? Please, if you're watching the lecture, like it. If you have not subscribed us on YT, do subscribe us. Okay, from May, as I've told you earlier, I'll be coming up with term 1 syllabus from tomorrow. So yes, from tomorrow we'll be doing term 1 physics as well. Okay, term 1 physics for class 10 rather. Chal. Okay, let's try do these questions. Let's try do these questions. A hammer exerts a force of 1.5 Newton on each of the two nails A and B. Okay, fine. The area of cross section of the tip of the nail A is itna. and that of B is itna. You have to find the ratio of the pressure. Okay, very very interesting question beta. Just see कैसे कर सकते हैं. Area of A is 2 mm square. Okay, now pressure is equal to force upon area, right? So PA so what will be the value of PA upon PB? I'm sure all of you have understood this. Now the pressure is same, so this gets cancelled. So I've solved it for you. The correct answer should be A. Yes, you will get these kind of questions, a lot of questions of these kind in your school exams as well. So make sure that make sure you're a part of it. Okay, next one. Just try it for 1 minute. I'm giving you 1 minute, whoever is there in the session, and then I'll tell you the logic. It's very easy. If you have understood the theory, you will be 200% confident with the answer. Yes. Just read the question carefully. Chalo. Yes, anyone? And please like the lecture as well if you're watching it. Anyone interested in telling me the answer? This is the question. Yes, come on. Any volunteer for the answer? I could see a few of you are watching it. Would love to hear it from any one of you. And yes, please like the lecture as well. Okay, chal. The mass here is given and it is 6.5. Okay. Now see, let me just tell you the dimension. The dimension of the block is 12 into 8 into 10. This is the dimension. But trust me, the question is asking the thrust, right? And when we started the session, I've told you thrust is nothing but the weight of the body. Yes? I'm sure you are able to recall it. Yes? Thrust is nothing but the weight of the body. Okay? So now tell me what should be the weight. You are given mass, and just by looking the values, the options here, you might guess that G here is 10 meter per second square. Yes? Excuse me. The value here will be 65 newtons. I'm sure you are able to get it. All of you. Okay, fine. Chalo. Now, this particular part of the session was dealing with the pressure part. Now we'll be dwelling into the upthrust and all. Okay, that is equally important. That is equally important. So for understanding the upthrust part, the very first thing that you should know is fluids. Okay, I did have a mention about fluid in the first part of the session. Now see, any substance that can flow is a fluid. Okay, any substance that can flow is a fluid. Now all liquids and gases are fluids. Yes, we have an idea on this. All liquids and gases are fluids. Now what about a solid? If you are excuse me, if you are having a solid lying on a surface, let us assume this is a surface, and a solid is lying on it. Okay, now what will happen? This solid will exert pressure only on this part, right? The part which is actually in contact with the solid surface will be acted upon by the pressure. All the other, I mean, this part is not exerting pressure or force anywhere, this nowhere, this nowhere. Okay, whereas if I say that this water bottle is having water, I mean water is a liquid, a fluid rather, which can flow. Now you can clearly see, if this is the water is applying a pressure on all the surfaces, right? All the parts, right? It is exerting a pressure in all the directions. I'm sure you are able to get it. The water filled in the bottle will exert a force, a pressure rather, in all the particular directions. So this is the difference between the pressure exerted by a solid and fluid. And how can you validate this? You can validate this through a very simple setup. This is a container having liquid. If you create a hole, I mean orifice here, you'll see that the water starts coming out. Okay, this is your reference point. H1, H2, H3, right? So you can clearly see that depending on the variation of the height of the orifice or the height of the liquid from the free surface, you can imagine the pressure exerted. Okay, the orifice at the bottom, I mean at a very low height, will send water to the farthest distance. Why? Because the pressure is greater. So in order to understand how much pressure actually acts or is exerted, we have to consider all the factors which affect the pressure at a point. Okay, the very first is the depth of the point below the surface. Now I've just depicted this. यहाँ पर देखो आप, I've just depicted it, right? जैसे जैसे आपका pressure बढ़ेगा, the water can move to a larger distance, right? I mean, let me call this X, let me call this Y, and let me call this Z. So you can clearly see for Z, the flow is up to the largest distance. So yes, the pressure at Z or Z is greatest. The pressure at Z or Z is greatest. This is how it works. Yes, I'm sure you are able to understand how it works. Kind of. Okay, chalo. Now let's see the different factors which affect the pressure at a point. The very first point I've cleared, the depth part. The second is the density. Density. Abhi density, how does the density affect? Now if I tell you कि मेरे पास दो बॉल हैं, एक मेरे पास से आयरन का बॉल है, एक I have got a wooden ball, right? I mean I have a wooden ball and I have an iron ball, and I drop both the balls, or I put both the balls on the surface of the water. Now tell me what will happen. I mean, which of the two balls will shrink and which of them will float? Obviously, I guess you have an idea that a plastic ball, or maybe a wooden ball, it might not sink in, whereas an iron ball will definitely sink. So that means, abhi in layman language, had it been a non-technical session, मैं आपसे पूछता कि ऐसा क्यों हुआ, तो आप बोलते कि सर वो भारी है इसलिए चला गया, है ना। आई मीन नॉन टेक्निकल रिप्लाई टू दिस क्वेश्चन इज कि सर वो भारी है इसलिए डूब गया, द अदर वन इज हल्का इसलिए सर वो नहीं डूबा. That is okay. I mean that you have drawn this conclusion depending on the observations. आपने ये कई बार देखा इसलिए आपने conclusion बना लिया. Technically speaking, density is the reason here. Okay, density is the reason here. वो भी मैं आगे के sessions में बताऊंगा how density affects. But yes, density indeed is very crucial factor in deciding whether a body will float on a liquid or it will sink. Okay, yes. Now there are few other parameters as well which normally all the students are confused about. Okay, हम सभी लोग इसको लेकर confuse रहते हैं. The very first is the shape size of the vessel. कोई फर्क नहीं पड़ता, ठीक है ना. शेप और साइज से कोई फर्क नहीं पड़ता, फर्क डेप्थ से पड़ता है. आप किसी भी शेप का ले लो लिक्विड, ये वेसल, आपके लिक्विड का डेप्थ क्या है, that will decide what is the pressure, right? The second one is the area of the surface on which the pressure acts. नहीं सर, ऐसा नहीं होता है, ठीक है ना, ध्यान रखेंगे. चलो, these are few laws of fluid pressure. Just take a moment, take 1 minute or 2 minutes and just go through this slide. Okay, just go through this slide and I'm sure you will be getting few very new points, very new points. Okay, just go through the slide first and then I'll explain you all the laws in detail. Along with the derivation for upthrust and all. See, the very first point we have already communicated. In a stationary liquid, the pressure is same at all the points. I'm sure many of you might have heard this law. Yes, and thus this particular law uses the same concept. अभी नहीं करना है अपने को, 11th में करना है, so we'll do it that way. Okay, and yes, let me just draw a liquid, a vessel having a liquid, and if I take a point here, now the pressure about the point will be same in all the directions. I mean whatever pressure it is getting from here, all the pressures will be same. Okay, yes. Now the fourth point, this is important. The point says pressure at the same depth is different in different liquids. मतलब क्या कह रहा है, the question, the point that needs to be conveyed here is, you are having water, you are having kerosene, you are having say oil or maybe any other liquid, and you are dropping the same body in all these 3-4 liquids whatever you have taken. Okay, now the pressure will be different in different liquids. Okay, now why is it different? Why is actually the pressure different? Because if you have changed the liquid in which you are kind of putting the object in, the density of the liquid is also different, right? I mean water, kerosene, any 2-3 liquids, they cannot have the same density. Yes, and I've already told you here that density is an important parameter. So yes, density does affect it. Now I've missed one of this, acceleration due to gravity. So that is G, which is very much present there. Actually the pressure, I mean if I combine all these things, the pressure becomes H rho G. You have to learn this and remember it. I'm just telling you. Okay, H is the height of the water column. Now this might be a new term for many of you. We'll be calling it rho. Rho, I mean crying wala rona, rho, and it will be density. Okay, and G, I'm sure you know what is, that is acceleration due to gravity. Okay, Just go through this upthrust. Very, very, very easy, very easy. I'm sure you have noticed that whenever you immerse a body in a liquid, it experiences a force. Yes? Yes, it is clear. Now the question is, what is this force and what is this property of the body? See, the force is called upthrust or buoyant force, and the property, okay, I've written it. The property is called buoyancy. So please don't confuse with buoyancy and buoyant force. Buoyancy is the property, okay, right? Inherent property, which normally we have to calculate, right? So that is buoyancy. चलो अभी ये सब छोड़ते हैं, सीधे तुम्हें अपथ्रस्ट का मतलब समझाते हैं. I'm sure that will be very, very, very interesting. And one more thing, very, very, very interesting thing. Let us take a liquid. Okay, and atmospheric pressure is not neglected. Atmospheric pressure is not neglected. Okay, it's very much there, very, very much there. So what will happen if I say that you have to find the pressure at this point? So total pressure will be atmospheric pressure P naught. Normally, I mean, every educator has a different symbol for it, but normally you can call it P naught. Okay, plus pressure at this point. Let us assume that this point was at a distance of h. So pressure here is rho GH. Okay, so always remember, in total pressure, when you have to find the total pressure, you have to add the atmospheric pressure, right? Make a note of it. You have to add the atmospheric pressure unless it is not mentioned. Unless it is mentioned, okay, ध्यान रखोगे. If it is mentioned कि you don't have to add atmospheric pressure, don't add it. Otherwise you should add it. Okay, always keep this in mind. These are very small points which make your numerical sometimes very difficult, which I don't want my learners to happen with them. Is it clear, beta, all of you? Yes. Okay, so now if you're having a book, you can clearly see that there are certain applications as well, but rather dwelling into the application part, I would rather love to help you with the derivation part कि ये आया कहाँ से. So if you are able to decode the logic behind it, now it will be a cake work for you. Otherwise so you will be having a tough time doing these questions. Okay, chalo, let's do it, and then we will be getting back to the slides, the theoretical slides. Okay, just let me tell you the concept behind it. This is a vessel. Vessel is filled with water. आप water मान सकते हो. And what we have done is, we have considered an imaginary surface now. See, these are 2 points on the surface. Okay, 2 points. One is the point A, the other one is at the point B. The height of the water column is h. Okay, बात समझ गया. पानी का लेवल h है. टॉप को मैंने A बोल दिया, बॉटम को मैंने B बोल दिया. Is it clear to all the learners who are watching this? Okay, fine. Now see what can happen. मुझे एक बात बताओ. I have told you that the pressure depends on the height, right? So tell me, PA is greater than PB, or PB is greater than PA, or PA is equal to PB. Which one should be the correct part? Which is the correct part? See, the height of B from the free surface. Many of these students start taking the height from here. No, height from the free surface. So height for point B is greater. So pressure at B will be greater. Okay, right? Now, in order to understand thrust, the basic logic is, जब आप किसी बॉडी को किसी लिक्विड में इमर्स करते हो, so what happens? You experience a force. Now the logic is, where does this force come from and why does this force act? Okay, if you go to the concept of Archimedes principle, you will understand that every body which is immersed, partially or completely, it will displace a liquid equal to the weight of the body that is immersed. जितना वेट का बॉडी आपने इमर्स किया है, उसी के करस्पॉन्डिंग वाटर लेवल डिस्प्लेस होता है. ओके, राइट? यस, आई एम श्योर यू आर एबल टू कनेक्ट इट. अभी मेरे को बताओ, इस सिलेंडर, ये सिलेंडर कितना पानी ले सकता है? सीधा सा फंडा. सी, द वेट ऑफ द वाटर इज m into g. Weights are always mass into acceleration. Now we know that density is equal to mass into volume. Yes sir, we know this. I'm sure all of you know this. Yes. Now I can replace m here. In place of m I can write rho into v into g. Yes. Yes. Now what is volume? We all know that volume can be written as area into length into g. Is that okay? Volume can be written at area into length into g into rho. By rho और l तो थे ही, आपने area into length और add कर दिया. Is it clear? Now this weight is nothing but thrust. We have just studied it in the previous class. The weight is nothing but the thrust. And what is pressure? Pressure is thrust per unit area. Yes, pressure is thrust per unit area. So what is pressure? Thrust is rho into A into L into G. There is A से A gets cancelled. तो rho G H by L है, L length ही तो है, I can take it H, right? In some cases it can be taken H. So I'm sure you have got the topic, how this upthrust comes and where did it come from. I'm sure you have got it, got the logic clear. Just give me a moment. Okay, now you can just go through these slides. I'm sure now you have understood this. Just take 1 or 2 minutes and go through the slides. Yes, I mean, this point is important. This point is important. In fact, very, very important. Very, very important. Upthrust becomes maximum when the body is completely immersed in the liquid. I mean, it will, displace maximum liquid when it is completely immersed. See, the entire body will be down, and when the entire body will be within the liquid, equal amount of fluid will be displaced. So this is how it goes. I'm sure you have understood this. Okay. Next one, this one. Just go through this. Just go through this. Right, and this is a very, very, very relevant example. I mean, ऐसा नहीं है, we are moving in air and air is a fluid, so yes, thrust is there. Okay, I mean, every year a number of students ask me this question कि सर क्या मतलब एयर में भी थ्रस्ट है? हाँ सर, एयर में भी थ्रस्ट है, बिल्कुल है, ठीक है ना, एयर में भी थ्रस्ट है. Okay, just let me check how many of you are actually there. Okay, ठीक है ना, तो एयर में थ्रस्ट है, ध्यान रखेंगे ये बात, डोंट गेट कंफ्यूज्ड कि सर एयर में थ्रस्ट है कि नहीं, एयर में थ्रस्ट है, राइट। अभी just look at this example. This is a better replication, a better measure for this. Excuse me. Right, density plays a very important role, right? You have filled a balloon with hydrogen, which is obviously less denser than air, so it does rise up. Fine. देखो मैंने क्या बोला था आपको, when the density of the substance is less, it never drowns down, it never moves down, it ideally floats on it. अभी air, if we are considering air as a fluid, what will happen? Air is a fluid, right? And you have a substance, or a balloon rather, which is filled with a gas whose density is less than air. So obviously, because of the difference in the density, the balloon will rise up. Yes, these are very practical examples, guys. Okay, few very important characteristics which come in 1 or 2 marks question. They are very relevant to the chapter. Just go through them. I'm sure you'll be able to understand it. Pretty sure. The very first point is self-explanatory. Larger the volume, obviously, it can be rethought in a different way. If you completely immerse the body, the thrust will be greater. So when they are talking about the larger partial or maybe the complete volume, so the point relates to the previous point. So that point, this is self-explanatory. We have discussed this point earlier as well, so I guess that doesn't count for it. Let's talk about the second point. For same volume, now see in the very first case, in the very first point, the volume that was submerged was different. I mean, अभी एक को मैंने 1/3 डुबोया, दूसरे को 2/3 डुबो दिया, ठीक है ना, I mean पानी के अंदर. So obviously 2/3 का volume मैंने ज्यादा किया हुआ है, volume is greater, so thrust will be greater. But now here is, I'm saying that I have fixed the volume. Okay, two bodies, same 1/3 volume is immersed, right? Now what will happen? Fluid with a greater density will be experiencing greater upthrust. Okay, so this is where the density comes into play, right? I'm sure you have understood this, all of you. Great. Chalo. See, this center of gravity, we have been talking about it quite often, quite frequently in a number of sessions. देखो, अभी you are in class 9, so you have to make a habit of remembering that everything acts at the center of mass, okay, or the center of gravity. Center of mass or center of gravity for a rigid body, I mean, normally they are same. Normally, not every time, but abhi till class 10th for you they'll be same. Okay, so this is a very good information for you, being a class 9 student. Now Archimedes principle, I mean, already we have discussed this, we have done the mathematical proof as well, so I guess that is self-explanatory. When a body is partially or completely immersed in a liquid, it experiences an upthrust which is equal to the weight of the liquid displaced by it. So this is Archimedes principle, right? A very important question for your exams rather. So, and in subsequent sessions we'll be doing numericals on it as well. ठीक है ना, अभी May we'll be doing a lot of numericals on fluid pressure because a number of students I have seen they find it difficult. So yes, this is an important thing, right? Chal. This a very important announcement from this one. There is a new batch called Challengers. The batch is starting from 26th of April 2022, right? It's an English batch. So the batch has already started yesterday. It's a English batch. Manan sir is taking maths in it. Shivam sir is taking physics in it. Ritika ma'am is taking chemistry and Bhavna ma'am is taking biology. Now the catch here is, if you're a class 9th learner and you're subscribing for class 9, you'll be getting subscription for 10 to 12th absolutely free, right? This is the catch here, and you can use the code Kalyan Live, right? You can use the code Kalyan Live to get the subscription, right? You'll be till midnight today, you'll be getting 20% discount. I've already shared the creative in the beginning, so I mean that is a very good opportunity. You can avail this. Now we have one more batch, the English batch, that is for class 10th. Again, see, this was for class 9, this is for class 10. Manan sir is taking maths, Shivam sir is taking physics, Ritika ma'am is taking chemistry, and Bhavna ma'am is taking biology, right? So this is the other batch that we are having. Then guys, we have a class 9th batch. We're calling it Eternals, right? I mean, this is an English batch, and Hina ma'am is taking maths, I'll be taking physics, Manisha ma'am would be taking chemistry, and Vani ma'am would be taking biology, right? Fine. Okay. Fine, great. And one more batch, we're calling it Hercules. Again, this is an English batch. This is an English batch. And Hina ma'am, maths, I'll be taking physics, Manisha ma'am will be taking chemistry, and Vani ma'am will be taking biology. A very important announcement that Unacademy has introduced with this community, the community feature, and through community you can be connected with your educator. You can get access to all the sessions, all the questions, rather all the PDFs of the sessions. So that is a very good thing which you should make use of. And then we have this bugs bounty offer as well. In case you have found any of the content inappropriate in the session and you're the first one to report, you can claim your prize, right? So that is all from my side. If you've not subscribed us yet, do subscribe us, click on the bell icon, like the video, share it with your friends, and I'm sure we'll be coming up with many such videos